Alright, this is day 2 in our unit on working with exponents, and we are continuing to simplify exponents and practice working on that. So let's see, looking at problem number 1 as an example, anytime you have a power raised to a power, that is when you multiply. So this is going to be n to the 12th power. On the other hand, when you are multiplying, notice that the n appears twice. That is when you add these exponents. So this is going to be n to the 11th power. See the difference? One base, two powers, that's when you multiply. If that base appears twice, that is when you add. Looking at number 3. Be careful, the 4 and 5 will just multiply as usual, so that'll be 20. N to the 5th power times n to the 3rd power, I'm going to add those exponents just like I did on number 2. So this will be n to the 8th power. P to the 4th power times p is p to the 5th power. Some kids feel like they need to put a little 1 here to remind them that we're adding 4 plus 1. I would prefer if you understood that p to the 4th power means p times p times p times p, and of course a single p from this guy over here would be like this. So altogether you've got p to the 5th power. I prefer that you understand what's happening rather than just blindly adding the numbers. Anyway, but this is the answer. So looking at number 4, watch out, you see that negative inside the parentheses and it is being squared. When you have an even power like this, whether it's 2 or 4 or 6 or whatever, a negative like this is going to change to a positive. So this is going to wind up being 16 n squared and then p to the 10th power. So what's happening inside of here is similar to problem number 1. If you have a power raised to a power, you multiply. That's why we did 5 times 2. Again, some kids like to put a little 1 here and think, oh, this is 2 times 1. But again, I would prefer that you truly understand what's happening, which is this. If I were to ignore the 4, the negative 4, and if I were to ignore the p to the 5th power and just focus on the n, what I have is n to the 2nd power. So of course it'll be n to the 2nd power. Number 5. The fact that it's a fraction doesn't change the way any of this works. 3 to the 2nd power is 9, just like it would be if I didn't have a denominator. A power raised to a power, I multiply. So that'll be x to the 8th power. And then again, if I scribble out all this stuff, I have y squared. So that's just y squared. Okay. Number 6, remember, anything to the 0 power is 1. So because this entire thing is being raised to the 0 power, the answer is simply going to be 1. Looking at number 7. Now the shortcut is to subtract, okay? So most kids will look at this and think 12 minus 3. Right, so that'll be p to the 9th power. And that is correct, and there's nothing wrong with that. But I do encourage you not to write this down, but I encourage you to think of this problem in the following way. I might have to zoom in so it'll fit. Okay, I encourage you to think of this problem this way. P to the 12th power is 12 p's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, that's p to the 12th power. P to the 3rd power is p. All right, if these 3 p's in the bottom cancel out 3 of these p's, then you see what's left is 9 p's. I'd prefer that you think of this process as canceling out p's, division, rather than switching it to blind subtraction. There are certain kinds of problems you will get into if you blindly subtract all the time. Okay, so looking at number 8, as we do this division, 20 divided by 5, obviously don't subtract. We're going to divide like you have done since 3rd grade. 20 divided by 5, of course, is 4. All right, so that would be 4. And then, and the way I think of it is 6 p's in the top, 1 p in the bottom. This p is going to cancel out one of these p's, so that's going to leave p to the 5th power. All right, if you are a blind subtractor, then you will put a little 1 here, and you will go, oh, that's 6 minus 1. All right, that's fine and dandy, but you will run into trouble if later on if you just blindly subtract. I prefer you think of this as 1, 2, 3, 4, 5, 6 p's over 1 p, and these cancel out, and that's why there's 5. Okay, trust me, man, you will be better off if you think of it this way. Obviously, we don't need a 1 down here, only when it's in the top. Now, number 9. I prefer you to think of this problem as I described before. Okay, n to the 4th power, that's n times n times n times n. Okay, n to the 12th power. Okay, all right, so there's n to the 4th power, and here's n to the 12th power. So what's really happening is these 4 n's are canceling out 4 of these n's. So what is that going to leave and where? Well, that is going to leave 8 n's here in the bottom. Okay, so I need a fraction to show that this n to the 8th power is in the bottom of the fraction. There's nothing left in the top, so we will put a 1 there. Anytime you're canceling things out, like when I do n over n, it's just like when I do 3 over 3. Anything divided by itself is 1. So when I'm canceling things out, canceling out these n's, I'm really dividing something by itself. I'm getting 1. So it makes sense that this is going to make 1 if that's the only thing left. So that is what you're going to have. Now, if you are a blind subtractor, then what you do is you go, okay, this is n to the 4 minus 12th power. Okay, now some kids just go, oh, so it'll be 8, and they just put n to the 8th, and they forget the 1 altogether. All right, based on what I just showed you, you can see why that would be wrong. It definitely has to be in the bottom. Look, that's where all the extra n's are. They have to be in the bottom. So other kids will understand that 4 minus 12 is negative 8. Please understand that you cannot leave your answer as n to the negative 8. It's not incorrect, it's just not finished. So if you do get n to the negative 8 power by subtracting, understand that n to the negative 8 power is equivalent to 1 over n to the positive 8. And go ahead and make that change before you call yourself finished. Okay, moving on to number 10. All right, with that in mind, keeping in mind that n to the negative 8 is 1 over n to the 8, keeping that in mind will help us understand this. K to the negative 4 power is the same thing as 1 over k to the 4 power. All right, so this would be 1 over k to the 4. But then p to the negative 3 is the same thing as 1 over p to the 3rd power. All right, please don't make 2 separate fractions. All right, this is just one fraction. That's the answer. Okay. Now, looking at number 11. Just take it one part at a time. Let me get my fraction going. We've got the 8 and the 2. All right, 8 divided by 2 is 4. 4 in the top. That's where the bigger number is. All right, so that 4 is going to be in the top. Now the x's. All right, focus your eyes right here. I have 9 x's in the top and 3 in the bottom. These three x's are going to cancel out 3 of these x's, and that's going to leave 6 x's in the top. Yes, 9 minus 3 is 6. Thinking of it as canceling out makes it more obvious where to put the result. Obviously it goes in the top because that's where the leftover x's will be. Looking at the y's, okay, same thing. Think of it as canceling out. In your mind, picture y, and down here picture 6 y's, all in a row. These 2 y's are going to cancel out 2 of these y's. How many y's are going to be left? There will be 4 y's left, and they will be on the bottom. Again, if you think of it as canceling out, it will be obvious to you that the y's that are left will be on the bottom, because that's where there are more. That's where the extra y's will be left over. Okay? So that's it. That's how you do number 11. Okay, looking at number 12, same thing. Start with the 4 over 12 part. Alright, you're basically reducing this fraction. Alright, 4 goes into itself 1 time. 4 goes into 12 3 times. So 4 over 12 reduces down to 1/3. Okay? So there's that. We reduce just like we learned to do back in elementary school. Now, looking at the b's. Okay, looking at the b's. This b cancels out one of these 6 b's. So how many b's will be left? Well, that's going to leave 5 b's on the bottom. That's where the extras are. Okay, now look at the c's. Alright, I've got 2 c's on the top, I've got 8 c's on the bottom. These 2 c's are going to cancel out 2 of these c's. That's going to leave behind 6 c's on the bottom. That's where the extra c's are. Okay, so this is your answer to number 12. You need that 1 up there. If 1 is the only thing there in the numerator, you need to keep it sort of as a placeholder to show where the denominator is. Alright, let's find number 13. Okay, to me the best way to think of these problems where you have negative exponents sometimes in the numerator, sometimes in the denominator. Think of it this way. The negative exponent is letting you know that this particular variable is on the wrong side of the fraction. So if you see a variable with a negative exponent, if it's in the bottom, it's going to move to the top. If it's in the top, it'll move to the bottom. Once you make this move, it's going to become positive. So basically this p to the negative 7th power is going to jump up here and become p to the positive 7 power. Alright, and that's the only thing that's going to change in this problem. So the answer would just be 3n squared p to the 7th power over 5. That's the answer. Okay, again, if you see a variable with a negative exponent, move it to the other side of the fraction and make it a positive exponent. Okay, that's the easiest way to think of it. So when you look at this problem, I have 2 negative exponents. So this one is going to move down in the fraction. Okay, so I'm going to have an x to the 4th power in the denominator. And then this one, the y, is going to move up. Okay, so I'm going to have y to the 6th power in the numerator. So basically these are going to switch places. Notice the 5 does not move. This negative exponent only pertains to the y. The 5 doesn't travel with it. Okay, so for that reason the final answer is going to be, look, see, let me start with my 5. There's my 5 that didn't move. This y went up, so I'm going to have y to the positive 6 power. This x went down, so I'm going to have x to the positive 4 power. Alright, so that would be my answer number 14. Look at number 15. If I were you, I would move anything that was negative before I got started. So to that end, hopefully you see that we've got this one variable with a negative exponent. So it has to move to the other side. So this p to the negative 6 is going to drop down to the bottom and become p to the positive 6. Alright, so that is now gone because it's down here. Then you can go ahead and continue and do the rest of the problem. Okay, so now if I will do the 9 and the 6 now. Focus on that. 9 over 6, you know, both of these are divisible by 3. So we're dividing by 3, we are dividing by 3. That's how you reduce. 9 divided by 3 is 3. 6 divided by 3 is 2. So 9 over 6 reduces to 3 over 2. Alright, now focus on the ends. Okay, I've got 4 ends in the top, 1 end in the bottom. This end in the bottom is going to cancel out one of these ends in the top. So how many will be left over? And where? There will be 3 ends left on the top once this cancels out one of these. Obviously it'll be on the top because that's where there are more. That's where the extras are. Alright, and finally now we can deal with the p's. Remember, this p up here is gone. It's down here now. So these are the only p's that I'm looking at. These are now on the same level. So just like we did previously in this lesson, to multiply these, we will wind up adding these exponents. So this will be p to the 8th power. Alright, so that would be the answer to number 15. Alright, what else you got for me? Okay, number 16. Now the easiest way to do this, I mean there's more than one way, but when I see a problem like this, I would go ahead and you know how if you have a power raised to a power, you multiply. So we're going to wind up, or one way to approach this is to go ahead and just multiply first, and that's what I recommend. So a power raised to a power, you multiply. So this would be m. So now negative 4 times negative 2 is positive 8. 5 times negative 2 is negative 10. So there I multiplied everything. Now I will do what I just talked about. You can imagine that there's this invisible fraction bar right here because you know, anything is kind of over 1, if you will. But I'm doing that because I see that I've got this negative exponent right here. So that tells me that I'm going to have to take this and drop it down to the bottom. So I'm going to wind up with v to the 10th power down here. Okay? So then that's going to be my answer. So my final answer will be m to the 8th power over v to the 10th power. That's my final answer. So again, multiply, and then I see the negative exponent. I just drop that variable down. Okay, I think this is the last problem. So there's really not much to do. It's pretty straightforward and simple. I see this negative exponent. It needs to drop down. Okay, so this is sort of my invisible fraction bar right here. And so when this drops down, I'm going to have x to the 3rd power down here in the denominator. Guess I should make this more like that. Kabam! So once that drops down, obviously it won't still be up there. So my final answer is going to be 5 y to the 7th power over x to the 3rd power. Okay, let me just zoom out to make sure I got everything. Yep, that was it. Okay, so this has been our lesson on working with the properties of exponents. I hope it has been helpful to you, and if so, a like is always appreciated. I will see you on the next video.